All right, so anytime that you do these percent yield problems, you are going to follow these steps. So you're going to recognize that the majority of these steps were actually what you learned yesterday with just molar ratios and stoichiometric calculations. The only thing new that we're adding is the percent yield. This is the only new part. So, first step. For any problem, you want to make sure that you have a balanced formula. So in this little problem here, they gave us a formula. You can check that it's balanced. I see coefficients. It means it's probably balanced. You should always check though, just to make sure. I see that there's 3 coppers on both sides, there's 6 chlorines on both sides, and there's 2 aluminum on both sides. So this one's balanced. So number 1 is done. Identify the actual yield. So the actual yield will usually be in grams, and they'll tell you like, hey, we actually made this much of something. So let's read the problem. So they give us the equation here, and then they say, if 3.4 grams of copper 2 chloride react and 1.4 grams of copper are formed, determine the following. So from here, they tell us that this is the actual amount of stuff we made. We made 1.4 grams of copper. So that is the actual yield. So we are paying attention in this problem to copper. Copper is one of them, and the other one is copper 2 chloride. Copper 2 chloride is right here. So we need to compare these two. All right. Second one, or third step, use the amount of reactant given to calculate the theoretical yield. The reactants are on the left side of my arrow, and specifically the one that they're talking about is this one. So determine the, so it says to determine the, use the amount of the reactant given to calculate the theoretical yield. Again, the theoretical yield is like in the perfect world, how much would we produce if absolutely nothing went wrong. All right, so let's do this one. So determine the amount of reactant to calculate the theoretical yield. This is the part that's going to take probably the longest amount of time. So let me scooch up here. So based on our molar ratios, I know that we are comparing these two things. We're comparing copper 2 chloride and copper. So I see that the ratios of these are 3 and 3. For every 3 copper chlorides, I have 3 coppers. 3, 2, 3. If I divide both sides by 3, I get a 1-to-1 ratio. 1-to-1 ratios are really easy to deal with because whatever mole value you get, it's just going to be equal to, and you don't really have to do that ratio formula or that ratio fraction that we did on Tuesday or Wednesday. So let's start. 3.4 grams of copper 2 chloride. To compare, we need to turn everything into moles. So I need to multiply this by the molar mass to get rid of grams and end in moles. So that means I have to have grams at the bottom, moles at the top, and I end up with moles. So I'm going to quickly cheat here and look up the molar mass of copper 2 chloride. You also should practice calculating this straight from your periodic table, but for the sake of me showing you, I just look it up. So I know that copper 2 chloride, CuCl2, has a molar mass of 134.45 grams per mole. All right. So if I need to turn this amount of grams for copper 2 chloride into moles, I have to do my little dimensional analysis using the molar mass. So I have 134.45 grams per 1 mole. I see that my grams cancel out. I'm only left with moles, which is what I wanted, and now I just have to do the math. So 3.4 divided by 134.45. And that is about 0.025. 0.025 moles of CuCl2. Now that I have this amount of moles for my reactant, I can use it to find how many moles I should have of my product, specifically copper. Because it has a 1-to-1, this amount of moles is going to equal the product's amount of moles. So I should be expecting 0.025 moles of copper. That is what I am expecting. That is my theoretical yield. However, in order to compare yields, percent yields, I have to have things in grams, or at least in the same units. In this one, it's grams. So let me turn this amount of moles of copper into actual grams. All right, so moles to grams of copper. I can quickly look up copper molar mass on my phone. You should do it on the periodic table since it's the only thing that you can use. And I know that Cu has a molar mass of 63.546 grams per mole. If I start with 0.025 moles, I need to multiply by something to get rid of moles, so I have to put moles at the bottom, grams at the top, 63.546 grams per 1 mole, cancel out my moles, and I'm left with grams. And when I look at that, that is 0.025 times 63.546. That is about 1.59 grams of copper. So in a perfect world, oh, you can't see that. In a perfect world, if everything worked out, I would have this much copper produced in my reaction. This is my theoretical yield. But I actually have this much copper produced. So now it's my last step, which is actually percent yield. Calculate the percent yield using my equation, which is this one. Percent yield is going to equal actual over theoretical. So actual of 1.4 divided by theoretical, which is what we found right here. This is my theoretical of 1.59 times 100. So times 100. This is my formula for my percent yield. So all I have left to do, super easy stuff. I just have to say 1.4 divided by 1.59 is equal to times 100. So my percent yield for this problem is equal to 88%. And that is it. So I found my actual yield of copper that they gave me, theoretical yield, found it by doing my molar ratio of the reactant that they originally gave me, and then I found my percent yield using the formula.